So example 3 wants us to prove the alternate interior angle theorem. So if we read the previous 3 slides, they were the alternate interior angle theorem, the alternate exterior angle theorem, and the corresponding angle theorem. And all 3 of these theorems are very similar. They both say if you have 2 lines that are parallel and are cut by a transversal, then the resulting alternate interior angles, alternate exterior angles, or corresponding angles will be congruent. So for the alternate interior angle theorem, it's telling us if the lines are parallel, right, M and N are parallel, then the transversal is going to intersect them and create alternate interior angles that are congruent. Okay, so that's what we're trying to prove here in example 3. They give us a hint, right, saying to use same side interior angle postulate. So we're going to do that. So first step of any proof is what's given. So we're going to write our given, M is parallel to N. So that's going to be step 1. Right, this is the parallel symbol, the 2 lines right next to each other. So M is parallel to N. That's also indicated in the diagram with these little orange arrows. Okay. Now let's use our same side interior angle postulate. So that says if the lines are parallel, and they are, then the same side interior angles are supplementary. So we're going to say angle 1 and angle 3 are supplementary by the same side interior angle postulate. Okay. If they're supplementary, we know supplementary means that the measure of the angles adds up to 180, so we can set up an equation there. We can say the measure of angle 1 plus the measure of angle 3 equals 180. That's what supplementary means. So we know the measure of angle 1 plus the measure of angle 3 equals 180. But if we notice here, we also have a linear pair. 2 and 3 are a linear pair. And so we know by the linear pair theorem that the measure of angle 2 plus the measure of angle 3 equals 180. So we can come up with a second equation here, right? The measure of angle 2 plus the measure of angle 3 equals 180. And that is your linear pair theorem is much better than what they have here. They have angle addition postulate. The angle addition postulate does not tell us that it adds up to 180, though. We would have to first state that there's a straight angle. So don't really like that. It should be the linear pair theorem is much better. Linear pairs theorem tells us if 2 angles are a linear pair, then they the measure of their angles adds up to 180. So that would be much better there. Again, this is the inconsistency that I don't like in the envision here with these proofs. We either assume that that's 180 or we don't. I don't like that. Okay, linear pair theorem is a much better response here. Okay, since they both add up to 180, we can either do substitution, right? We can substitute in the measure of angle 2 plus the measure of angle 3 for 180 here, and get the measure of angle 1 plus the measure of angle 3 equals measure of angle 2 plus measure of angle 3, right? We could, let me draw it in here, right? We could substitute this in for here, right? And replace 180 with this. Or we could use the transitive property. Let's see which one they did. Okay. They use transitive. Okay, either way, it's the same outcome, right? Replacing this 180 degrees, substituting in this will give you this whole thing here. Or you can use transitive, right? Transitive is if 2 things equal the same thing, then they equal each other. So both of these, the measure of angle 1 plus the measure of angle 3, and the measure of angle 2 plus the measure of angle 3, they both equal 180, so you can set them equal to each other by the transitive property. Right? But substitution would have also worked there. Okay, we notice we have plus measure of angle 3 on both of them, and we're trying to get angle 1 and 2 by themselves. So we can use the subtraction property of equalities to subtract the measure of angle 3 from both sides. And that leaves us the measure of angle 1 equals measure of angle 2. And by the definition of congruent, we know that if 2 angle measures are equal, those 2 angles will be congruent. So angle 1 is congruent to angle 2 by the definition of congruence. Okay. So that one's fairly straightforward. Yeah, now you have the try it, which is to prove the corresponding English theorem, which is very, very similar to what we just did.